Assalamualaikum and good day everyone. This is Sked Code of 5424 and our topic for today is heap data structure. So what is heap data structure? Heap data structure is a complete binary tree that satisfies the heap property, where any given node is always greater than its child nodes, and the key of the root node is the largest among all other nodes. So it means heap is a special type of binary tree used in computer science to efficiently manage a dynamic set of elements, particularly for operations like finding the minimum or maximum value quickly. So heap is a special type of binary tree, like what it said, and used in computer science to efficiently manage a dynamic set of elements, particularly for operations like finding the minimum or maximum value quickly. So we have two key properties of heap data structure. We have complete binary tree, in which all levels of the tree are filled, and efficient operation. It's allow a quick access to the root or the minimum or maximum heap and efficient insertion and deletion of elements. We also have key properties, the two properties of heap data structure. We have the maximum property or maximum heap property and minimum heap property. The max or maximum heap property is any given node is largest among others. Ibig sabihin, ang node po is always larger. From the word max or maximum heap property, any given node is largest among others. And in the min heap property, always smaller than the child nodes, and the key of the root node is the smallest among all other nodes. So it means it's baliktaran po. In English, it's synonyms. Max is the largest, while min or minimum is the smallest. For example, we have here the sample of the maximum heap property. As you see, the maximum heap property, the parent node is 9, and 9 is the largest among all other nodes, while in the min heap property or minimum heap property, the one or the child node is the smallest among other nodes. And this type of data structure is also called a binary heap. Moving on, we have heap operations, and some of the important operations performed on a heap are described below, along with their algorithms. So, we have example with their algorithms here, and number one is Heapify is the process of creating a heap data structure from a binary tree. It is used to create a minimum or a maximum heap. So our operations is called Heapify. It is a process of creating a heap data structure. So first step, we have to put the array or input array be an initial array. So our node, any given node, is put in initial array, where it begins with a 0 and with a 5, or any other given number of nodes. For example, here in the 0 we have the value of 3, in the 1 we have the value of 9, 2 the value of 2 also, 3 is the value of 1, while 4 is also same as the value of 4, and 5 is the value of 5. So we see here from the first step that 1 is the largest among all other nodes, while in the tree, in the value of 3, which is 1, is the smallest among other nodes. So in the second step, we are going to on the second step of 5. So we see here from the first step that 1 is the largest among all other nodes, while in the tree, in the value of 3, which is 1, is the smallest among other nodes. So in the second step, we are going to we're going to create a complete binary tree from the array. So here, like what I said earlier, on the 0, which is the top node, we have the value of 3. And this is what we call a complete binary tree. We're just going to put each value on their designated numbers. Then, step 3, start from the first index of non-leaf node whose index is given by n/2 minus 1. So, in the step 3, we are going to do the first step in the leaf node, which is the 2. And the given equation is n/2 minus 1. So, start from the first on the left node. So, we have the value of 2 over there, which is also the 2. And that is our leaf node. Then, set current element as I as largest. Element 1 as largest. So 1 is our largest, which is 9. And the fifth is the index of left child is given by 2i plus 1. And the right child is given by 2i plus 2. So, if a left child is greater than current element, for example, element of I index set like this, set left child index as largest. So, the largest is the value of 1, which is 9. And if right child is greater than element in largest, set right child index as largest. Then, swap largest with current element. So, like what it says here, we have to swap the current element. Then, step 7, repeat steps 3 to 7 times until the subtrees are also heapified. So, swap if necessary until you get your satisfaction, or you become satisfied to the outcome of your heapify. And we have here the algorithm, or the insert element into heap. So this is the code. Heapify, open parenthesis array, size and I, then close. Set I as largest. Left child is equals to 2i plus 1. This is the solution. Right child plus is equals to 2i plus 2. If left child greater than array or the largest, set left child as largest. Just what we said earlier. And to create a maximum heap, we have also here an equation of max heap, open array, open parenthesis array and the size, then loop from the first index of none, then call heapify. For minimum heap, both left child and right child must be larger than the parent of all nodes. So as you see here, for example, in the 0, which is the value of 9, this is the parent node. Parent node is always the greater among other nodes. And the child nodes is the smallest among others. So, if there is no node, create a new node. Else, a node is always present. Insert the new node at the end. Then heapify the process. So, in step 1 of the insertion, insert element into a heap. Insert the new element at the end of the tree. So if you're going to insert any element or any nodes, you have to insert it on the end of the binary tree. So like what happened here, like what we did here, we insert the value of 6, which is the 7, at the end of the binary tree. Then heapify the tree. Yeah. You know the process I told you earlier. The first step, we have to look for the heapify the leaf node, which is the value of 2, which is 7, and look for the largest among others. So that's all. Thank you and God bless us all.